So I'm going to give a very quick talk about using spatialized data to help shape policies around school capacity planning and school diversity. And so I actually realize I have a lot to cover here, so I'm going to try and move quite quickly, and then if there are questions, we can chat and happy. So a little bit of background on me. I'm trained as an urban planner and a data analyst, and my passion really sort of lies at a basic level in how technology can help improve government services and policy decision-making processes, and then also how product-driven companies work with government and within the public realm to try and create public benefit. And I've been working for the last 4 years at WXY Architecture and Urban Design, which is a interdisciplinary planning, urban design, architecture studio in New York. And my role is sort of bringing together different data analysis and mapping and scenario modeling techniques to help our clients, primarily city agencies, make decisions. So there are several sort of challenging dynamics that kind of form the backdrop of this education policy work that WXY has gotten into. The first is that school district systems are kind of governed in equal part by policy and by place, and one is flexible and the other is not. And so, neighborhood change due to migration or new development or gentrification that has a strong impact on local schools, and policy needs to be responsive to that change. And also, when thinking about education policy, this is a really multi-layered, complex, highly scrutinized, and very high-stakes arena. And so everything that one does needs to involve a lot of consensus building. So I'm going to talk about 2 case studies where WXY was commissioned by 2 different city agencies, city departments, the Economic Development Corporation in New Rochelle and the Department of Education in New York, to look at different problems with a similar data set. And so in both cases, we had anonymized student address data, which was geocoded and associated with a number of other variables, including demographics, the characteristics of the household housing, the sending and receiving schools from the elementary to middle school to the high school level, and the choices of the students and where they were given offers. And all of this is very sensitive information, which we've gotten in partnership with our work with the school districts, and we've taken a lot of precautions around sort of the privacy and anonymity of what we show in talks like this and through the process. So in the first project, the city of New Rochelle was facing a sort of downtown rezoning, which would permit an additional 5,500 new multifamily units, which would be concentrated in the downtown area in a transit-oriented development, which would also fall within one elementary middle school zone and affect those schools disproportionately. And so we were brought in to help quantify the real impacts of this kind of new development product in New Rochelle, these higher-rise multifamily buildings. Oh wow, 2 minutes. To think about how to plan for the impacts on the school system. And so our point of departure was this industry standard Rutgers demographic multiplier, which uses the census ACS PUMS product, but it's aggregated to the state level. It's based on 2000 data from 2000, and there's a very large sample size that's broadly aggregated. And so when we tested what these numbers predict from the observed student generation in 3 multifamily buildings in New Rochelle, we saw that these numbers are really off. And so we started asking questions about who lives in these multifamily transit-oriented developments, how does housing structure type, tenure, number of bedrooms affect student generation. And we did see that these transit-oriented developments have this concentration of 18 to 44-year-old families, and then also an uptick around 75. And so these are two demographics that have very specific patterns of family, household sort of demographics. And so we took this geocoded data and created a baseline enrollment projection around the population, population projection system-wide, but then we also looked at these three very specific buildings to understand how many students had been generated by units with the studios, 1 bedrooms, 2 bedrooms, 3 bedrooms, and by the tenure type in order to get real observed multipliers, which we could use as a benchmark, and then pulling this custom query from the latest PUMS file that's very specific to the geographic and programmatic profile of the buildings that were coming in to the city. We're going to run out of time, so I'm just going to try and get through this project, and I'd love to talk about the D15 diversity plan at the happy hour. But we, ultimately, through these custom multipliers, which were based on these observed generation rates that really depended on having this granular geocoded student address data, we were able to create multipliers that ultimately, our PUMS query matched what was observed in our sample by almost 99%. And so we could get a much more accurate sort of picture of what the impact of these new developments would be, and that helped us set an effective impact fee with the developers, helped us think about relate that to a tipping point analysis and think about when a school the specific elementary school might need to expand or build a new school. And that it also helped with the sort of, the city holding the developers accountable to the right fee.